So next up is the collision system. Um, so the user does have the ability to select which collidable they want to use. If you see here, it'll just say set collider model. If you go in there, you have an enum basically to pick whichever one you want, and then by default you're going to get a collision value sphere, even if we have we'll have two basically B spheres if you picked B sphere. So walking through each volume, the B sphere is pretty much the same, except we are using the visitor pattern now. So then the AABB has accessors, and then also the visitor pattern. And then here, when we initialize it, we are doing the calculations to get the min and max for the AABB. And then in every update, we call compute data, which re-updates the min and max basically. Go. So I have it, since I didn't make a base class, I have to have it for a little more separated, as you'll see a little later. So I have different ways to compute the data. And then I have, this is for, I believe, collision testing. Yeah, okay. So the OOBB, looks pretty similar, except the obviously we don't have to just keep track of the min and max. We need to this one just is not axis aligned. So when we compute data, we're basically doing the same thing. And then this one I found a little bit easier, but I'm trying to remember. It's been so long since I worked on this collisions. So yeah, so then we are using, sorry, I'm looking at the document. We are using the visitor pattern for all of these. If we go into like I said, I didn't have a base class, so if we go into our math tools, I do have intersections for each one. Basically, I did it pretty much manually. It was extra work, but tools, math. So here you'll see that I have to test for overlap between an OBB and an OBB, to OBB and an ABB. And then I have to project, I would make the projections work with both and whatnot for the OBB collisions. Yeah, so then with the collidable groups, we have a group ABB, and so that's being calculated in ABB. So I go calculate ABB, compute data, and then we take the collection. Oh yeah, this is what we saw earlier. This is not for, so sorry, I've been up for like 48 hours, but yeah, so we basically go through everything, update the min and max, getting the minus min and the maxus max out of the collection to make a group ABB, AABB, and we do that only once per frame because it is called leave. Here. So when we process collisions, we calculate the AABB for each collection, and that obviously process collisions is called once per frame. The collidable manager, new process triggering collision group updates. Yep, we saw that. The destructor with proper cleanup. Yep, we're just going through the collection and the test commands. And we're cleaning that up. Collision tests. Const references. Ideally. So let's go to the command tests, and you'll see that I do use references as much as I can. And then we have the hierarchy here. So it's best, I understand it more in the pair. So basically we grab the two groups, we check for the two groups colliding, and then we check the B-sphere. If they do collide, then we check one of the collection's B-sphere with the other group. And then if those do connect, then we check the object that worked with looping through all of the group objects. And then if one of those work, we go ahead and do a regular collision test, which is obviously most costly. So then we're visualizing that here, and then we call our callbacks. So then for the self, it's a little bit different because we don't have groups. So basically you just skip all the group stuff and then you just test the B-spheres pretty much. I do have a terrain command. However, I am not doing this the efficient way. So we'll talk about that later, but yeah, that's here too. Okay, and I think that's it for collision.